Hey everybody, thank you so much for joining our webinar today. So as you all are aware, we've been hosting a series of webinars over the past few months where we've dived into different aspects of the software modernization journey. So far we've talked about the general journey towards modernizing from legacy application systems and coming to more modern cloud native approaches. We've talked about architectures and different development paradigms as well. Today, I have Chad with me, and we're going to be talking about what are all the different security mechanisms that we use in a modern cloud native architecture. So if at any point in this webinar you have any questions, feel free to drop them down in the comments, and we would be more than happy to answer them. So as you all already know, I'm your host, Siddhant Khisti. I'm a product executive at Devtron, and I'm also the organizer for Cloud Native Community Groups of NASA. Chad, would you like to give yourself a quick introduction?
Yeah, my name is Chad Crowell. I am founder and instructor at KubeSkills. I've been in multiple DevOps and SRE and platform engineer roles in the past. I've been in this industry for over 15, maybe over 16 years now. And so I've had my fair share of, security events, and, hopefully I can be of give you some pointers here and to point out some things to be aware of as we move into this kind of this new world of AI and with cloud native systems overall.
Awesome. Thanks for sharing that, Chad. And for folks who are not aware, Chad recently released his latest security course. So I'll drop a link to that down in the chat so you folks can go ahead and check it out. Chad, maybe before we move forward and get started, you would like to give a quick overview about your course?
Yeah, so I think this is a unique course in that it focuses on GitLab and Kubernetes specifically. And so we learn how to deploy workloads using GitLab CI/CD and also through the lens of Kubernetes. So what that means is using Kubernetes as a runner and executor, and also using Kubernetes as the endpoint for our deployment or where we're deploying our workloads to. And so we learn different techniques for security throughout that process that we can bake into our CI/CD pipeline and make sure that security, before we even deploy to our cluster, we can implement these certain things in our pipeline to secure our workloads and to make sure that we have limited vulnerabilities.
Awesome. Thanks for the quick overview, Chad. And we already have a show of support from Utkarsh that he got to know about KubeSkills recently. So yeah, folks, if you're looking to brush up on security knowledge, please do go ahead and check out KubeSkills. I will drop the link down in the chat. And also, if you are interested in the entire modernization journey and the different aspects about it, please do scan this QR code and you can watch all of our previous webinars. And I promise you that you will get great value out of them. So without further ado, let's go ahead and get started with our agenda for today. So before talking about how the entire security posture has evolved for a more cloud native ecosystem, a cloud native world, let's have a short discussion about the legacy security mechanisms. So before cloud native, we had things like perimeter security. We had tons of different firewall implementations and many other things. So Chad, maybe you'd like to go ahead and get us started with what these legacy mechanisms were and why were they essential before a world of cloud native?
Yeah, so back when I first started my career, there was a lot of there were a lot of attack vectors and points to which you could easily attack any company's system. And we used to implement even though it was in our servers and our data center were locked behind closed doors, there was still these issues of having thousands and thousands of servers with their own operating systems to patch and their own vulnerabilities, each with different versions, and so lots of attack vectors there. And then also it's managing all of those disparate systems, and usually before microservices, we had our applications built as a monolith, and therefore you couldn't upgrade one component without upgrading another, or you couldn't update them separately. So this allowed you to get more lazy in terms of not updating your systems for fear of taking the whole thing down, your whole application down. And so if you didn't have those built-in kind of maintenance windows where you had customers aware of my app is going to be down for a certain period of time on this specific date and time, that created a lot of problems and allowed a lot of these security issues to fester. And then when we're talking about how you would get around that, is just apply more firewalls and more VPNs and more, which some not always the best, not always the best case in terms of again, having to manage all of those different systems and different mechanisms and different tools, and also it just creates more and more avenues and attack vectors for a potential attack.
Awesome. So yeah, like even traditionally we were using monoliths, right? And now the whole landscape has changed to using different microservices. So in the era of monoliths, as you mentioned, right, we were using a lot of firewalls, multiple firewalls. And to some extent, that even slowed down the network request or just the overall developer velocity, as we would say. So, what are your thoughts on how we have evolved from many firewalls to what we have today?
Yeah, as you mentioned, it definitely doesn't help latency. And before the cloud, we didn't have things like CDNs or opportunities for us to place our workloads closer to our customers. So the availability and the opportunity, right now I'm in Spain, for example, and let's say I wanted to access an application that lives in a private data center in California. It would be I would have a different experience than somebody who was local. And in addition to that, going back to talking about firewalls and it just creates another barrier to get through, and to have to manage these firewalls, and being able to set these. Sometimes the firewalls were too passive. Sometimes the firewalls were too aggressive. So sometimes in a lot of events that I've fallen victim to, and also heard about in the news, sometimes we would be actually blocking our customers or people that we would want to let through because our firewall rules were too strict. And the same goes for allowing too loose of rules and allowing potential attackers through.
Awesome. So that's how we had a lot of systems in the past, right? And now that we're shifting to the cloud native era, a lot of different things have changed. So monoliths have turned into microservices. We've got everything running in containers. When deploying to Kubernetes, you've got tons of different services, and to manage that, you've got a ton of different API calls that are happening. You've got services, and just the entire attack vector, as you would call it, it's increased quite a lot. So the scope of attack also, I would say, in some aspects, it has increased, and the complexity to manage all of that also increases, since in microservices, we're treating every tiny component as its own individual application. So it has its own security considerations that we need to go through. So Chad, my question to you would be, what are some of the challenges that you are seeing that arise when we're talking about security in the cloud native world?
Yeah, I think first and foremost, misunderstanding the the your responsibility. There's this thing called the shared responsibility model. I'm sure everyone's heard it who's worked in the cloud, but there's the responsibility that you take as a customer, and then there's the responsibility that the cloud takes, or the cloud service provider, whether it be Amazon or Microsoft or Google. And so misunderstanding where those lines are drawn, right, and what you're responsible for, I think, is the biggest misstep that companies have when moving to the cloud. So understanding that just because your workloads are in the cloud, there's certain security measures taken, and it's secure by default, which is absolutely wrong, especially if you're just running infrastructure as a service. I would argue that some of the platform as a service and perhaps the software as a service offerings that those cloud providers have may have security built in. However, if you're running an EC2 instance in the cloud as is, there are certain measures that you'll have to take to make sure that your infrastructure and your applications running on top of that infrastructure are secure.
Right. And even when we move to the whole cloud environments, right, we've got containers to consider about when running in Kubernetes. So what are all the different considerations that we need to have for Kubernetes, the different pods, the different secrets, API tokens, which we have? Like, there are secrets, we know that, but as anybody who has worked with Kubernetes on a production level knows, secrets are not secure by default, since they simply have an encoding which can be cracked quite easily. They're not exactly encrypted. So in that case, we've got best practices of using external secret stores. So similar to that, what are some of the best practices which folks should follow while they're working on Kubernetes, especially Kubernetes that's in a cloud provider? So let's say EKS, for example.
Yeah. So you mentioned secrets, and you're exactly right. Secrets are not only can be decoded very easily, but also when they are there's in transit, and then there's at rest. When they are at rest in the etcd data store, they're actually not encrypted at rest, even though they may be in transit via TLS. So that's definitely why tools like Vault and these encryption providers that provide secure secrets exist, and one exists for each cloud provider as well. But when we're talking about Kubernetes, we have the ability to create containers. A lot of people think that because we have a container and it's it's not tied to an operating system, and it's kind of abstraction of sorts from the kernel, it's secure by default, right? And that couldn't be any farther from the truth. So just because you're running in containers, actually, because you are sharing the same kernel, maybe potentially has equal, if not more, security risks associated with it. So when you're running in Kubernetes, there's an encapsulation of that container inside of a pod. That pod provides the ability to share storage and networking between multiple containers in the same pod. And this the smallest execution in Kubernetes is a pod. And so you have these pods which run your workloads that are ephemeral in nature, in that they will be spun up and terminated, sometimes on a moment's notice. Sometimes they're moved from node to node. And so this opportunity that we have to run these kind of in stateless workloads or mutable infrastructure, this is actually a good thing, because your workloads are constantly changing, and you don't have this kind of stale state that goes along with your workloads, and therefore prevents a lot of misconfigurations, or prevents a lot of risks from a security standpoint as well. But when we're talking about Kubernetes cluster, and the cluster itself, it's running its own API, and it's a REST API, and it's considered an application just like any other application, comes with its own security risks. So we have I guess one of the strong points of Kubernetes is that it has a kind of a single endpoint, or a single way of getting into the Kubernetes cluster, or getting into the API. And in a lot of cases, we use RBAC, which stands for role-based access control, to access some of the items that exist within the API, such as deployments, pods, replica sets, stateful sets, etc. And then authenticating to the API in the first place usually takes place with either X509 certificates, or using SAML or OIDC, or some kind of integration with the cloud provider. You mentioned running something like a managed Kubernetes service, either EKS or AKS or GKE. In those cases, they kind of take away some of the responsibility. We talked about the shared responsibility model earlier, and what the cloud providers do in that case is take away your responsibility to secure the control plane. And in the Kubernetes cluster, there's this concept of a cluster that consists of the control plane components, and then the worker node components, or the workloads that are running your applications. And so when you go with a managed service offering like EKS, AKS, or GKE, you're no longer responsible for securing the Kubernetes API. But still, like I said, there's the workloads, much like in the case that I mentioned before, and when you're running infrastructure as a service in EC2 instances, or Azure virtual machines, or otherwise, there's still that security that you have to be aware of, that securing the apps themselves, the apps that are running on the worker nodes in that cluster. And so when you're running your workloads in your cluster, and running those workloads in a pod, there's certain security mechanisms within the pod and at the API level, or things that you can enable at the API level that enact or enforce at the pod level, such as pod security standards, pod security admission, and then pod security context, which allow you to enforce certain things to be in place on that pod, such as this pod cannot run any containers that run as root, and enforcing that, so that if that doesn't take place, if that is not enacted on your cluster, then the pod will never get scheduled and never start to run. So those are just a few things that we think about when securing our workloads, both from whether you're managing the control plane or not, and then also the responsibility that you have when you're running your workloads on pods.
Awesome. I really love all those points which you've made. And we have the 4 C's of cloud native, right? Which is cloud, cluster, container, and code. So I believe we've covered the mechanisms for securing 3 of these layers. The only thing which we didn't touch upon a lot is the code aspect. So maybe for the developers in our audience, maybe you could shed a little bit of tidbit on how folks can go about securing the code.
Yeah, definitely. So first and foremost is the vulnerabilities that exist in the code, and sometimes developers don't realize that their workloads have a number of dependencies, whether in the image or in the packages that are running the application itself. So sometimes, and you definitely should have this if you don't already in your CI/CD pipeline, something like Trivy, being used to detect those vulnerabilities and give you a report on, what is vulnerable in your cluster, and if those things don't check out, meaning if you have vulnerabilities that are higher risk, that workload should not be deployed. And so there's vulnerabilities that may exist from the image itself, the image that's being used with the container, or the underlying code. There's the dependencies, the package dependencies, and also the image dependencies. And then there's the code itself, and is it are we using dry principles, so do not repeat yourself, and being able to build the application in a way that's using minimal images and images that have less surface area to attack.
Awesome, love that. And you mentioned about securing the application straight from the CI/CD pipelines itself, right? And I really love that, and especially that you mentioned Trivy. Like Trivy is quite an amazing tool. Like putting on my Devtron hat for a few seconds, we use Trivy natively within our platform as well, just because it's a great tool for scanning security risks, security vulnerabilities, right? And we'll get into the conversation about securing applications straight from the CI/CD pipeline a little later in this discussion. But first, what I want to talk with you about is how the different threats have evolved. So before we got started with the webinar, backstage, I was talking with Chad about the cryptojacking state, right? So when you're running pods, especially in production, you might have a lot of use cases where all of the resources in the pod are not being utilized. So in that case, an attacker might find a way to hijack your pod and do something like crypto mining. So that's your resources are getting starved. The actual application might not get enough resources for running your business critical application, and in the overall picture, that will have a big impact on your business applications as well. So Chad, could you walk us through how threats have evolved from the old days where everything was monoliths, and what are the threats which we need to keep an eye out for today in a distributed architecture such as in Kubernetes?
Yeah, so we talked about monoliths before, right? And that in some ways was a good thing, because you had less points of attack and less ways to get access to this component over here, which would then lead to this component over here. So in the past, I think we because our infrastructure was sometimes private and in a data center, maybe in our building, we could take more preventative measures to secure it, and to only allow a certain number of IPs, or maybe a certain number of requests in, or whatever the case may be. You could take measures, more fine-grained measures, I should say, and be able to lock down, and being that it was a monolith, it was easier to do so. And so as we shift to a cloud native ecosystem, and the ability to utilize different availability zones and different I mentioned CDNs, content delivery networks, that allow you to basically have either a cached version or another replica of your workload in another place throughout the world. And as we talk about distributed systems, we're talking about maybe you have an edge location that's different than your primary data center, or maybe you have mobile devices that are connecting back to home base. So a lot of these things that are really really good things that could allowed us to expand our footprint and take advantage of this spread out nature of the for lack of a better word, spread out nature of our our cloud resources, sometimes that creates a greater risk of exposure. One of the things that came to mind when talking about cryptojacking is back in 2018 when and this was a while ago, so I'm sure most people are familiar with it, when Tesla exposed their Kubernetes dashboard and was a victim to cryptojacking. So this was as a result that it was because they had deployed their Kubernetes dashboard without any credentials. So you could access that from the public. Anybody could access their dashboard and make modifications to their Kubernetes cluster. So this was back in 2018 as the example that always comes to mind when thinking about how we can secure our Kubernetes clusters and our kind of cloud native resources as they become more and more distributed. And then when it comes to when it comes to the microservices and the more modern distributed systems that we're building today, there's a lot of requests that go from system to system, and instead of this being a big monolith and maybe the front end has direct access to the back end, or the middleware is right next to the database layer, or what have you, it's a lot easier to make those calls. Whereas today, it's an API call or an HTTP request to this microservice over here, which then runs the risk of potentially being intercepted, or potentially being sending out a signal and not getting an acknowledgement. So stuff like man in the middle attacks and things like that set us up for potentially a greater risk of attackers. So when we think about in the context of Kubernetes, coming back to Kubernetes, and this is my kind of specialty, so this is what I've been focused on for the past 6 or 7 years, is making sure that when you deploy your dashboard, in the case of Tesla, not only requiring credentials to be provided and for you to have to log into that dashboard before viewing it, but also just making sure that your RBAC configuration is configured correctly. So you're following the principle of least privilege. So no one person has more access than they need, and there's also this concept of zero toleration, or zero. So basically, you're treating everything as somebody coming from the outside. So I'm blanking on the name right now for some reason,
Zero
but
trust.
Zero trust. Thank you. Zero trust, and so that's how we should be treating our systems as a result of our systems being more distributed and preventing some of those security risks that I mentioned before. In addition to that, like I mentioned before, Kubernetes is a REST API. So being able to hide that API, make it private in some cases, so that not just anybody could access your Kubernetes API. And in addition to that, with Kubernetes having kind of a central API, it runs the risk of denial of service attacks. So we have distributed denial of service, which allows us to either if our API is public, being able to send thousands or millions of requests to that API, or in the case that you have one of your workloads exposed via load balancer, or gateway API or ingress, targeting that and sending thousands and millions of requests to that as well. And so that's where we get into rate limiting and being able to control who and when they're sending those increased number of requests. Once you get inside the cluster, there's this concept of network security policies. So being able to control the ability for one pod to talk to another pod, whether they exist on the same node or not. Network policies are a good way to restrict communication from, so to make sure that your front end pods only have access to your database pods and no more. And so network policies allow us to do that. And then if we take a step back and think about the admission process. So in Kubernetes, there's authentication, authorization, and admission. So being able to mutate, certain objects in Kubernetes, and also, be able to allow admission, or to be able to allow you to create certain resources anew. For this, we use products like or tools like Kyberno or OPA Gatekeeper to make sure that when we go to create something or to modify an object, that's hitting some kind of security gate first. If those security measures are accepted, then we can go ahead and create that deployment or create that secret. We talked about secrets before, or create that config map or any one of the Kubernetes resources. So I think I kind of went off on a tangent there. So I'll let you bring us back in.
Sure. Like there are way too many things which you mentioned, and the entire security landscape is quite huge in itself. If we dive into every single tidbit of security, I'm pretty sure we might have a 10-hour long webinar easily. That's like the minimum for security, since it's such a vast thing. So there was one thing which you mentioned about Tesla, which I had an interesting thought around. But first, we have a question from the audience. So Utkarsh is asking, in addition to cryptojacking, what are some of the different types of threats that a pod is vulnerable to?
The biggest one is running your containers as root. So if you're able to have root access to the pod, in many cases, not all cases, you could potentially have the ability to gain root to the node that it's running on. As I mentioned before, the container is just an abstraction, or a through the ability of C groups and namespaces being able to share the kernel, being able to share the node's kernel. So there's this thing called a container escape, where we can gain root access to the pod, and therefore gain access to the node that is running that pod, and then allows us to break out into the node and then control everything on that node. So that's the biggest thing. And then also having the I mentioned pod security context, so we can limit the pod to only running as a certain user, obviously not a non-root user, through pod security context, and that's configured at the pod level. So when you're creating the pod YAML, the YAML spec to create a pod, that can be enforced. And then there's the network policies that I mentioned before, which control the pod to pod communication. So those are the two big ones.
Awesome. So moving on to our next topic of discussion is balancing security with velocity. So in terms of security, there are a lot of different things which we implement, right? So like you mentioned earlier, there is a ton of network policies, authorization, like normal Kubernetes policies, who can make certain edits to the secrets or the deployments or the pods, etc. So all these different things, at some level, they will slow down developer velocity. So let's talk a little bit about how we can strike a good level of balance between securing the entire system as well and not compromising on developer velocity. So in the previous discussion, you mentioned about Tesla exposing their entire Kubernetes dashboard, right? So what exactly is a Kubernetes dashboard? It's simply a single point of contact where you have access to all of your Kubernetes related resources, correct? So what are your thoughts on having such a central dashboard, and what are the steps that folks can take to make sure that access to that dashboard is secure? Because again, at enterprise scales, everyone needs a dashboard at some point, whether it's your default Kubernetes dashboard, whether it's a platform like Devtron, or a platform such as Backstage. We need it at an enterprise scale. So what are your thoughts on securing this kind of a dashboard?
Yeah, so I think providing that visibility, like you mentioned, it's a single point of entry, but it's also a single pane of glass to view your workloads and to see, to manage, especially if when you get into the hundreds or maybe even thousands of nodes in the same cluster, which I'm not going to say if I recommend or not, but you can see where your workloads are running and have more visibility into, potential workloads that may be more of a security risk than others, or being able to just see at a very high level what what is in use and what is being potentially misused. So I think dashboards are great. I think from a dashboard security perspective, I think having a dashboard that has the same level, or if not more, in terms of the RBAC configuration and the security controls that it allows. And so the dashboard is, just an application in addition to all the other applications that you're running in a cluster, needs to be secure at the pod level, as well as at the namespace level, and also at the API level. So being, following those same principles in terms of, applying, roles, role bindings, cluster role bindings, and only allowing, let's say you only allow view access to your dashboard versus, allowing administrator access to your dashboard, so that, you can maybe have that single pane of glass and be able to view all the workloads in a single pane and be able to tell what's, overall what's going on in your cluster. But maybe you can't make modifications to that. Maybe it's, you can only view what's going on, but then if you need to change anything, then you have to go into the command line. So things like that are really good, in my opinion, in terms of only allowing access, the appropriate amount of access that you would need, either at the user level or maybe at the computational level. As we know, we have this concept of users in Kubernetes, but we also have service accounts that are given tokens to access our API as well. So those are things to keep in mind. And then I should have mentioned that before. The other another security risk to our pods is allowing them through the token access, the token request API, being able to have the ability for that pod to have a token to then access the API, which is another security risk. But going off on another tangent again, bringing it back to dashboards, I think, just being able to restrict access, restrict, what you can do as a user, being able to access the dashboard. Obviously, not allowing anonymous access. Obviously, not allowing public access. So locking that down to maybe you only view the dashboard from a certain IP range, or maybe you only are allowed to make that request using a certain request header or something like that, and then hardening the RBAC policies to make sure that this person viewing the dashboard can only view pods as opposed to delete pods, or maybe even create secrets versus just viewing secrets, and maybe only limited to a certain namespace. We have a lot of developer teams within the same company. This dev team over here will be responsible for this namespace, and then this dev team over here is responsible for a different namespace, and then we have different policies and different security parameters and different security standards for each team.
Awesome. Thanks for sharing that, Chad. So coming back to the actual topic of discussion here, I know like security is such a huge topic. It's really difficult to not go on a tangent like that. So what would be the ideal way of enhancing developer velocity while maintaining security? Now, in actual enterprise environments, especially when you're trying to deploy to production, there are a lot of things which can slow down the developer velocity, right? So you've got approval checks. Unless you have proper approval from the owners of a particular API or a particular application, you won't be able to trigger the deployments for that. What if you have to push out minor bug fixes, critical ones, but small ones? You will have to go through that entire approval process again. Then within your CI/CD pipelines as well, you've got security scanning. In that as well, you can have certain policies which are going to restrict the deployment in case you have critical vulnerabilities, super severe vulnerabilities that are bound to be a risk, and in the past they have been a risk. So in that kind of a case, what would you suggest is the ideal balance between security and velocity?
In my opinion, and this is again in the context of Kubernetes and running your workloads inside of containers, is using minimal images and using images that contain little to zero vulnerabilities from the very beginning. So maybe you are running your vulnerability checks inside of your CI/CD pipeline, but the result of those security scans are lesser than if you're using, an image that uses the entire Debian operating system, for example. So ChainGuard actually has a lot of, zero vulnerability images that are secure and minimal. They're built that way from the very beginning, so you don't have to worry about some of the other vulnerabilities. And also they're distroless, so they're not running the entire distro, such as Debian or Ubuntu or what have you. Even Alpine sometimes can get a little bit heavy and therefore contain a lot of vulnerabilities. So running distroless images, and then you mentioned having detecting a bug in your code and then having to revert or patch that code or remove that for the next deployment, which could affect your release cycle. For that, I think what's a really powerful thing is being able to have a way to easily debug your systems, preferably inside of the pipeline. But also, if you take that out and being able to possibly take some preventative measures and being able to try to insert try to test some of those bugs in something like a staging environment or a dev environment first, and then being able to deploy once you've eliminated those bugs. So debugging containers are good for that. The recent release of Kubernetes allowed us to use containers as kind of a debug mechanism, to where you can deploy an init container which runs before let's just call it the main container, which allows you to do a whole host of things. They're used a lot in service mesh in terms of injecting a HTTP proxy, but they could be used for debugging as well. And then just having the ability to have these be able to spin up a dev environment in the case of whatever vulnerability or whatever bug you find, being able to quickly spin up a dev environment or a staging environment, make a quick fix, and then still continue on and maintain that velocity.
Awesome. Thanks for sharing all of those strategies, Chad. So we're running out of time, so I would like to really cover the next couple of slides quickly and then move on to the audience questions. So in your experience, what are the common security pitfalls that users might experience in cloud native environments and on Kubernetes?
Yeah, so talking about cloud native security pitfalls, I would say being able to, like we mentioned before, having your systems distributed throughout the cloud environment or cloud environments. There is hybrid environments still are very much a thing in today's ecosystem. And being able to secure at each point, whether that's in your main data center or availability zone, or your edge location, or in your CDN, etc. Being able to restrict and or control the requests that are being made to those distributed systems, and restricting API access, providing the zero trust model, like we mentioned before. Other pitfalls include, a lot of times, it's a lot easier to have infrastructure sprawl, in terms of the how easy it is to deploy workloads in the cloud. And so a lot of companies and a lot of people that utilize cloud resources, forget that they spun up an extra EC2 instance, or they spun up an Aurora database by accident, or it's so easy to create resources in the cloud. It could be easily. It's sometimes hard to manage when it is so easy, and then that creates just another point of attack, or the ability for you to be exposed when you aren't aware. So having awareness and keeping an inventory is always important. Other than that, there's a lot of auditing that you can do between these different systems of your application. So we can produce audit logs and be able to detect when a certain incident is happening. I know that there's a tool out there called OpenAppSec that provides you the ability to kind of detect an attack potentially before it even comes. So it's one of the only tools that is a kind of a 0-day attack mechanism. A lot of people don't think that exists, but that's in a lot of cases how we can use AI and machine learning to improve our security posture, is trying to figure out patterns, and that's what AI is good at, right? And detecting those patterns sometimes allows you to put up additional barriers to potential attacks.
Awesome. Thanks for mentioning all of those pitfalls, Chad. And your last point directly is tying into my final topic for discussion, which is using security for AI. Now, I know that a lot of folks are hesitant for using AI at any level for their environments, especially if it's production environments. Because what if AI gives a false positive, or a more risky thing is a false negative? So that's really risky, right? So in the context of security, how do you see AI being used today, and how would its usage evolve in the days and years to come?
Yeah, that's a good point. I just mentioned the ability to detect patterns in attacks, to protect yourself, and zero day attacks are a thing in which we have common vulnerabilities that exist in Kubernetes and everywhere that we need to be aware of. But the problem becomes once the vulnerability is detected, if at all, we have limited number of days and limited time to react and to patch our systems. So we in Kubernetes we have this thing called CVEs, common vulnerabilities and exposures and exploits, and being able to keep an keep an inventory of that, or be aware of that. But if a brand new CVE is released, sometimes we it takes some time to get access to that knowledge and be able to patch. So that's one mechanism to where we could use security for good with AI. Another is being able to. We mentioned before at the beginning of this podcast. We mentioned the ability to stand up a firewall to prevent, have these allow and deny rules that prevent certain traffic or deny certain traffic. Another a good use of AI is and machine learning is to be able to on the fly or intelligently detect and measure the rate at which we are denying traffic or allowing traffic. And we also talked about before the DDoS attacks and being able to detect detect when a certain number of requests, thousands or potentially even millions of requests are coming into our cluster all at once. AI and machine learning allows us to figure out that pattern faster and potentially automatically set that rate limit or block outright that IP wherever that request is coming from. The other things that I can think of are just in terms of running our workloads and becoming more efficient and that as we start to develop AI systems that are running on Kubernetes workloads. There's this project called Kubeflow that allows you to run your models on Kubernetes. Kubernetes potentially could allow faster access to could allow you to run those workloads faster and train your models faster. I think Kubernetes has the ability to do that, and the very nature of clusters and the Kubernetes API and the extensibility of the API. That's all that comes to mind. So I think those are good cases and things that are the good that can come out of security with AI.
Awesome. Thanks for sharing all of that, Chad. Like, I personally am really excited to see how is the use of AI going to evolve, not just in security, but other aspects of the entire ecosystem itself. So we've got KubeCon London coming up, and I'm pretty sure like there are plenty of talks related to AI and how it's being used in real world scenarios. So yeah, excited to learn more about this from all of that. So we've got just a couple of minutes left. Let's try to speed run through some of the audience questions. So we've got a question from Makendran, what security pitfalls emerge from poor implementations of zero trust in cloud native environment? I really love this question because most of the security vulnerabilities that I have personally seen, all of them stem from poor implementations or misconfigurations. So, Chad, would you like to give your 2 cents on the matter?
Yeah, I think in terms of zero trust, this could really allow you to shoot yourself in the foot in terms of locking you out to your own systems. And so, if you're following zero trust, in a lot of cases, have a backdoor policy or have a break glass policy is a better way of putting it, I think. And then being able to, fine tune that zero trust model and not block access to certain things that you may want to allow access to. So that's, I think, would be a poor implementation of zero trust. It's just, setting a blanket, nobody can access anything, and then you get into troubles that way too.
Love that. And you mentioned about implementing a backdoor, right? So this is, I would think of it as sort of an anti-pattern, because the first place that we're implementing all these security measures is to prevent unwanted access. And backdoors are a common way for attackers to get access to the system. So would you consider this as an anti-pattern?
Yeah, I think where you run into trouble is that being misused, and if that break glass is misused in any way, I think what you need to do is treat it like a real break glass policy, in which if those keys are accessed in any way, that being known by everyone and being detected almost immediately, and that runs the risk of that being misused in any way. But I think it is an anti-pattern in the nature of zero trust, and that you don't want to have the ability to skirt those rules and to get around the zero trust that you put in place. But at the same time, I think there are emergencies which require this break glass policy. So I think it's just it may be depending on your situation, and depending on the what is the risk that is involved with implementing a zero trust policy.
Awesome. So basically, if we're implementing this kind of a break glass scenario, have to take extra steps to make sure that even that is secure, right?
Mm-hmm. Yeah, definitely. So if it's truly a break glass, when you do break the glass, this is a fire alarm that gets set off, and everyone knows it and everyone's aware of it, and therefore this doesn't get misused and just allowed to be used whenever and wherever. This truly needs to be used only in emergency cases.
Awesome. Love that. So we've got a pretty loaded question here, and I'm sorry that your name is not rendering, but Suman asks, what are your thoughts on forensic checkpointing with Cryo?
Forensic checkpointing with Cryo. To be honest, I don't have much experience with this. I can't talk too much about it. Do you have any thoughts on this? I have little to no experience with forensic checkpointing.
Yeah, like even I have not delved much into the entire forensic science part of security, but I think maybe one of the things that, well, at least what I'm understanding from the name, is container signing might be one of the ways for implementing what Suman is trying to talk about.
All right. Yeah, we have for signing images. We have a tool called Notary, which is used in a lot of cases for signing images. I think it's a good thing, and as we start to use more and more container images, and especially if you're not building those container images from scratch, it's always a good idea to make sure that the image that you intend on running is in fact the image. So it's I think should be used in a lot of cases. Notary is the one that comes to mind. I'm sure there's others, but that one comes to mind almost immediately.
Awesome. And last question before we end it off. How do you think security risks differ across the major cloud providers that have Kubernetes services? So like across managed services like EKS, AKS, GKE, and others.
I think by their very nature, they both they offer different but equally as secure offerings. I think each major cloud provider has its own security as a service, if you want to call it that. I guess that's just kind of a white glove approach to providing security for whatever workloads you're running in the cloud. What comes to mind almost immediately is Azure Sentinel, in terms of providing kind of an event management kind of event-driven security posture, and so that's for Azure. And I think I think there's others as well. I think the major difference, I think, is in terms of security, we mentioned before about the control plane. If you're using a managed Kubernetes service, the control plane is kind of secured for you, so that's something that you can kind of not have to manage right off the bat, or not have to try to secure. And then the other, in terms of AKS, EKS, and GKE, they each have their own kind of implementation of event driven, being able to detect when your workloads running on those worker nodes that we mentioned before are either being compromised, or being able to collect logs through a logging mechanism, or being able to encrypt your data using encryption at the S3 level, for example, or even EBS. And then I think what Kubernetes offers, though, as a way to similarly run your workloads across many clouds and potentially multi-cloud. So Kubernetes itself, and the cloud native tools that go along with it that we've mentioned so far, like Hiverno or OPA Gatekeeper, or Notary, or Trivy, those are all open source and a part of the cloud native ecosystem. And so I think that is an advantage itself, because no matter where you're running your Kubernetes cluster, on whatever cloud provider allows you to a similar type of security mechanism or security offering from open source tools than you can get with the cloud service providers. So
Awesome. Love everything that you mentioned, Chad. And each cloud, at least as far as I've seen, each cloud provider has their own different way of implementing things. So that's also one of the biggest, biggest hurdles of getting to learn a new cloud provider. I remember when I was trying out Azure for the first time, I just could not get the clusters kubeconfig file. Like I had to go through 5 to 7 different security mechanisms. create this authentication group, sign in that way, just to get access to the cluster. And yeah, at one level, that is a bad user experience, I believe. But from a security perspective, I think like having such a system is quite great.
Yeah, there are a lot of open source tools available to you that I would encourage you to check out that will, in some cases, allow you to not only take control of the security posture that you have and put it back in your hands, but also allow you to potentially migrate from cloud to cloud and not being tied locked into any one particular cloud.
Awesome. Love the points which you've mentioned, Chad. And everybody, thank you so much for joining this webinar. If you want to learn more around this entire modernization journey and the different aspects of it, from security to architectures, once again, please do check out all of our webinars and do check out KubeSkills as well. I've shared the link in the comments below. And yeah, Chad, thank you so much for joining us today. Do you have any closing remarks that you'd like to leave our audience with?
I think you mentioned KubeCon coming up at the beginning of April in London. I'll be there. So if you're there, please send me a message on one of the social medias or get a hold of me through a couple of the booths that I'll be at on the showroom floor. And also, you mentioned the security course that was just released that goes through, what are the different security aspects to Kubernetes, but also what are the vulnerabilities and ways that you can protect yourself against attacks. So I would encourage you to check that out as well.
Awesome. So once again, thanks so much for joining, Chad, and thank you for our audience as well. And you'll ask some really fantastic questions and loved every aspect of them. See you all folks in the next webinar. And yeah, hopefully we can have Chad back for another conversation around some different topics as well.